velocity, vertical circular motion with variable speed. This was the question. This is the ground and this is the sphere. Radius of the sphere is r and this is fixed to the ground. At the top there is small body and the surface is smooth, therefore coefficient of friction is 0. The small body is slightly pushed, the body will move down. Question is, from where the body will detach from the spheres, actually surface of the sphere. And another question, what is the velocity at the moment of detachment? Okay, I am drawing the figure again. Let's see here. This is the ground. This is the sphere. This is the center. This is the top. Suppose from here, bird will detach. From here. At this moment, here u equal to 0, but here is velocity. What is the direction of the velocity? Tangent. Tangent and radius perpendicular to each other. This is the velocity. At this point, this is the body here. What is this? Sir, this is the mg. This is the mg. Please see here. What is this? This is the centrifugal force. This is mv squared by r. Another thing is important. What is this? Suppose this angle theta. What is this angle? This angle is also theta. Now, please see here. In this case, normal reaction is here. Normal reaction means this is the ground and this is the body. This acts as the mg action. This is the action, and the force applied by the ground on the body. This is the normal reaction. In this case, this contact surface, that is tangent, acts as the contact surface. Body is on this side. This sphere is the ground here. Therefore, this aim is applied by the sphere on the body. Ground on the body. This sphere acts as the ground. This sphere acts as the ground. Therefore, this is the direction of normal reaction. Now, please see. This is mg. What is this? This is mg cos theta. So what is the relation? Sir, m v squared by r plus a, this equal to mg cos theta. Okay. What is n? N equal to normal reaction. How long n is present, there is no contact detachment. When n is 0, what is the condition for detachment? Condition for detachment n equal to, sir, n equal to 0. Therefore, m v squared by r plus 0, this equal to mg cos theta. Please see here. M v squared by r plus n equal to 0. This is the condition for detachment from here. What is this? Sir, v square equal to rg cos theta. V square equal to rg cos theta. This is equation number 1. This is equation number 1. Next part is here. What is this? Next part. See here. Suppose you are taking this point is A, this point is A, this point is A, and this point is B. Here, what is this? Let's see. I am taking, sir, this equal to H. What is this? Whole thing is R. What is this? This is R minus H. This is R minus H. Is it clear from the figure? Now, see here. This is O. This is O. A, B, and this point suppose C. From triangle triangle, from triangle BCO. What is this? R minus H divided by OB. This OB equal to R. That equal to, what is this? With respect to theta, this portion acts as the base. What is this? Base by hypotenuse, cos theta. Is it okay? Now, it is R minus H equal to R cos theta. R minus H equal to R cos theta. From here, please take here, this side, H is taken this side and this portion is this side. What is this? 1 minus cos theta, this is equal to H. This is the H. Please, this is equation number 3. Equation number 2. Now, applying the law of conservation of energy. Law of conservation of energy. What is this? Et at A equal to Et at B. Ek at A plus Ep at A, Ek at B plus Ep at B. This is the law of conservation of energy. Now I am deleting this portion. Please see here. V square equal to Rg cos theta. Please keep here. V square equal to Rg cos theta. Now see here. What is the kinetic energy at the point A? This is velocity 0. What is this? Half m0 square. With respect to, this is the reference plane. Please see here. This is the reference plane. What is this? RP, reference plane. With respect to these reference planes at A, kinetic potential energy mg into h. What is kinetic energy at the point B? What is this? This is half mv square mg into 0. mg into 0. This is the reference plane. What is here? Therefore h is 0. Now from here, what is this? Sir, V square equal to 2gh. This V square equal to 2gh. This is equation number 3. Now compare 1 and 3. From 1 and 3, what is the language? Sir, from equation 1 and 3, we can write, sir, Rg cos theta equal to 2gh. Now put here, what is h? What is h? R into 1 minus cos theta. Now put here. From here, what is this? From here, sir, R cos theta equal to 2h. 2 into h. What is h? R into 1 minus cos theta. Okay? From here, I am just deleting this part. Again. Please see. I am deleting. Okay? See, this, in this case, what is this? R cut. What is this? Cos theta equal to 2 minus 2 cos theta. From here, this is 3 cos theta equal to 2. Which is okay? What is cos theta? Cos theta equal to 2 by 3. From the figure, can you tell me what is cos theta? From the here, this is cos theta. What is this? Cos theta equal to, this is the base, this is the hypotenuse. What is this? One thing is important. This is one question. What is question? From here, theta equal to cos inverse 2 by 3. This is, suppose, in which angle body will detach? In that case, angle is a question. In that case, cos inverse 2 by 3. This is one question. Now, I am putting, this is one question and answer is this. Cos theta from the figure, R minus H divided by R, that equal to, what is this? 2 by 3. From here, 1 minus h by r equal to 2 by 3. R by r cut, r minus r by h by r. Now, take this portion this side and this portion this side. What is the answer? Okay, it is completed. Now I am moving above. What is this? So from here, h minus r equal to 2 by 3 equal to what is this? 3 minus 2 by 3, that equal to 1 by 3. What is h? H equal to r by 3. From where? From where this is the answer? From where? From where this is the answer? This is one answer. And what is b square at this moment? Now, b square equal to rg cos theta. Rg cos theta. Or b square equal to, no, this is not answer. B square equal to 2gh. 2g. What is h? R by 3. What is b? Root 2 gr by 3. This is the answer. Now, this one answer, and h is this. From where? And this is the velocity. Question is, please say here, I am reading this question. Question is, suppose in the exam, this is the question. Please see here. Here to here, this is I have taken. This is the h. This is the h. In that case, please see here. In that case, h how much? This h equal to r by 3. Suppose this is the center. This is the center. In this case, what is the answer? This is h1. What is this? R minus h. What is r? R minus r by 3. In this case, 2r by 3. This is the answer. Okay. Now suppose with respect to from here, what is this position? What is this position from here to here? Suppose I am taking this distance is h3. This height is h3. What is h3? Can you tell me? What is h3? From here to here, what is this? From here to here, 2r. 2r minus h. 2r minus h. 2r minus h equal to what? R by 3. 6r minus r by 3, that equal to 5r by 3. Now, therefore, if the language is different, height will be different. Is it okay? But velocity is always same. Velocity is same. Height from with respect to ground, this is the answer. With respect to center of the sphere, h1 is the answer. Or from above, this is the answer h. From above. Below this highest point, this height, from this height, at this height, body will detach. Is it okay? No. Next part is very important. Please see here. That is moment of inertia. Moment of inertia. It is denoted by I. It is denoted by I. Now, I am giving, this is a body is here, and this distance is R. Here is the body. This is the mass. This is the mass A. Body is rotating like this. This line is known as axis of rotation. Axis of rotation. Axis of rotation. With respect to this axis of rotation, with respect to this axis of rotation, with respect to this I am writing AOR. What is this? AOR. Axis of rotation. I equal to, what is I? Moment of inertia. This part equal to mr square. This part is equal to mr square. What is the dimension? Dimension of I. This is the question. That equal to mr square. What is M? Capital M. What is R square? A square. What is the answer? mA square. What is the unit of I? Unit of I, that equal to kg. Please keep in mind I equal to mr square. So what is M? M in kg, and this is in meter square. Or this is dyne into centimeter square. Okay? Please draw this figure fast and write down. Next. Okay? Next. Now, first thing, in this case, known shape and known shapes and their eyes. Eyes means moment of inertia and their eye. Please try to understand. First, number one, I am drawing like this. Body is moving like this. This is the arc. This is axis of rotation, and this is the body. In this case, what is I? I equal to m r square. This is the figure number one. What is this? So this is the arc. What is this? This is the mass. Axis of rotation. Second, what is this? This is string. This is string. This is string. This is string. But now next part is very important. This is the I'm drawing like this. This here. This is the circle. What circle? Uniform circle of a radius of, this is radius r. Circle is moving. Here body is moving like this. Here whole circle is moving like this. This is the axis. Circle is moving. This is the axis of rotation. This is the axis of rotation. In this case, what is I? I is also mr square. mr square. This is mr square. Okay? Next thing. Figure number 3. What is this? This is from here I am taking from this circular disc. You can draw like this, or you can draw like this. You can draw like this. This is the center, and this is not the circular uniform circular ring. Uniform circular, this is the ring, and this is the uniform circular disc. This is a uniform circular disc. Is it clear? In this case, this is axis of rotation. This is axis of rotation. This is axis of rotation. The eye of this disc, this eye equal to mr square by 2. Please write down. This is figure number 3. This is figure number 4. Clear? Next thing. Next part, node shape. Next part is This is sphere. This is the center. This is axis of rotation. Its I, this is equal to mass, and this is equal to R. Here, this is known as hollow sphere. This is known as hollow sphere. Its I equal to 2 by 3 m square. Please write down. Hollow sphere 2 by 3. Same figure with little change. What is this? This is this like this. This is known as, what is this? Body is moving like this. This is solid sphere. This is solid sphere. What is this? Here I equal to 2 by 5 m r square. Please write down 2 by 5 m r square. Figure number 7. Figure number 7. This is uniform rod. Uniform rod. From here, this is axis of rotation, and here to here, this is L, and whole body, mass of the whole rod, M equal to mass of the whole rod, that's this. With respect to this, what is the formula? M is squared by 12. Please write down. M is squared by 12. M is squared by 12. This is figure number 7. This is figure number 7. Okay? I'm deleting figure number 8. Body is moving like this. This is hollow cylinder, and M total mass, and here to here, this is the radius. Cylinder. What is the formula? I equal to m r square. Looks like green. Looks like green. Yeah. Figure number 9. I'm deleting. Please go to the figure. Here is cylinder. This is the center, but this structure like this. This is solid cylinder. From here to here, this is R. A equal to mass. What is I? It acts as a circular disc. What is the formula? M r square by 2. M r square by 2. This is figure number 9. Okay, now this is 10. This is here to here, this is A. Here to here, this is B. Rectangular disc. What is this? Rectangular disc. Rectangular disc. Rectangular disc. In this case, total mass M. total mass of the disk. What is this? Rectangular disk. From here, please try to understand. Here to here, this is B by 2. Here to here, A by 2. Clear? Here to here, B by 2. Here to here, A by 2. This is a circular rectangular disk. From here, axis of rotation is passed. The body is moving like this, and this is perpendicular to the plane. Is it clear? Now I am drawing its axis. Suppose like this is the axis. It is in the vertical plane and the disk is in horizontal plane. Body, the disk is moving like this. In this case, what is I? I equal to M by 12 A square plus B square. A square plus B square. Now, if here A to B, if A equal to B, then it is called a square disk. A square disk. What is the shape? Here is the center. This is the axis of position of axis of rotation. Here I, what is the formula? I equal to M A square. In case of B, that is also a square divided by 12, that equal to M A square by 6. This is the answer. Okay? Clear? Now, here, moment of inertia, if the question is it is which type of quantity, vector or scalar, moment of inertia, I equal to a scalar quantity. Right? This is how I am giving one question. Suppose with respect to this here, this is a circular ring. Sorry. Uniform circular ring. Suppose with respect to this axis, this is axis of rotation. With respect to this axis of rotation, suppose its moment of inertia I. Moment of inertia I equal to I1. Suppose with respect to moment of this axis, moment of inertia is I1. Now question, with respect to this moment of this axis of rotation, what is I2? This is the question. This is in this position, this is I. In case of I2 with this axis of rotation, this is axis of rotation. So what is I2? What is it? What is that? Maximum student would write, sir, I2 equal to I1 cos 45 degree. That is I into 1 by root 2. That is I by root 2. This is not the answer.
Sine or?
No. Okay. Some students say, sir, I2 equal to I1 sine 45 degree equal to I into 1 by root 2 equal to I by root 2. This is not the answer. What is the answer? Answer is simple. I2 equal to I1 equal to I. It is the diameter, it is also the diameter. All the diameters of a circle are identical.
Oh, अच्छा.
This is diameter, this is also diameter. All the diameters are identical. Therefore, suppose some student will ask, this is 90 degree, this is 90 degree. It is with respect to this I3. This is also I1 equal to I. This is also diameter. All the diameters of a circle are identical. With respect to same and identical diameters are the same, and that's why it is the big scalar coordinate is the simple. Another thing is important. I resultant equal to I1 plus I2. This here, this formula is applicable. I square equal to I1 square, I2 square, 2 I1 I2 cos theta. This formula is not applicable. If this formula is applicable, in that case, sir, it is the vector quantity. Simple I resultant equal to I1 plus I2. This formula is applicable, this formula is not applicable. It is why this is not vector. This formula is applicable, this is scalar quantity. Okay? Now, another thing is very important. See, method of calculation of I with respect to different axis of rotation. Different axis of rotation. Please, in this case, we have two theorems. First theorem of perpendicular axis. Theorem of parallel axis. Please write down. Theorem of perpendicular axis and theorem of parallel axis. Theorem of perpendicular axis, theorem of parallel axis. Okay? Please here. Theorem of perpendicular axis. Now, give the heading. Theorem of perpendicular axis. What is plural of axis is axis. Clear? Plural of axis is axis. In this case, suppose I am drawing like this. And like this. Please here. This consider this circle in the horizontal plane, not in the vertical plane. In that case, sir, this is x-axis. With respect to this axis, this is ix. This is y-axis with respect to this iy. Clear? These two are in place here in the horizontal plane. This is not in the vertical plane. Consider this is in the horizontal plane. With this is a uniform circular ring. What is this? Uniform circular ring. It is uniform circular ring. Ring is in the horizontal plane. axis, y axis are also in the horizontal plane, and this is z axis. With respect to z axis, suppose this is the z axis. Clear? With respect to this, sir, this is IZ. This is IZ. With respect to this axis, sir, this is IZ. Is it clear? Now, theorem of perpendicular axis. Please try to understand. How many axes? 3. Out of the 3, 2 axes are in the plane of the body. One axis, this is axis. 2 axes are in the plane of the ring. In this case, which are? I, X and IY. Another axis, one axis is perpendicular to the plane of the ring. Please continue. Perpendicular to the. What is this? In this case, Ix and Iy in the same plane. That is in the plane of the ring. They should be added. What is the theorem? Ix, Iy, that equal to Ij. Please try to understand. In this case, their axis should be in the plane of the ring. And this is the resultant. It is clear? It is clear? Is it clear? I think clear. Now, please see. Some student can write like this: Iy, Iz equal to Ix. Sir, it is clear? It is wrong or right? It is also correct. When the ring is kept in the plane y and z, in that case this is the resultant. Similarly, you can write, sir, this is the z and this is the x, in that case the y. One thing is important. The component, these are the two component moment of inertia. The component in the plane of the body, component inertia should be present. And perpendicular to the plane, that should be the resultant. Is it clear? Okay. I am giving one question. Suppose, in this case, this is the circular ring. In this case, circular ring, and this is the tangent. Suppose in this case, what is the formula? Please try to understand. What is this formula? In case of n, sir, this is mr square. mr square. In this case, which formula is correct? Which formula is correct? This formula is correct. Here Iz equal to mr square, and here, sir, Ix equal to Ix, because Ix equal to Iy. Why? Because they are the same diameter. This is diameter, this is also diameter. Here, sir, Iy equal to Ix, this is I, this is it. These are the two diameter, same diameter, identical diameter. In that case, what is this? Sir, 2Ix equal to mr square. And what is Ix? Ix equal to mr square by 2. Okay? So what is the question? What is the answer? Here, how many? Ix, Iy equal to mr square by 2. But what is Iz? Iz in this case are mr square. Please write down. Is it clear? Okay. Next part is very important. Next part is very important. Next part is, please see here. Now give the heading: Theorem of parallel axis. Theorem of of parallel axis. First thing is here, please see how many axes? How many axes? In this case not 2. In this case are not 2. But these 2 should be parallel. Should be parallel. Now I have done this figure again. This. Now this is the tangent. This is the tangent. This is the tangent in the plane of the ring. Vertical plane. Tangent in the plane of the ring. With respect to this axis, the ring is moving like this. Please try to understand. The ring is moving like this. Whole ring is moving. Here is the contact. This I1 should be calculated. Now, here is important. What is this? This axis I am taking. What is this? I am taking this is I1. What is this? Please see here. In this case, this is H. This is H. One thing is important. Here I1 equal to here IY equal to MH square. What is H? This H is the what is this? Please see. H is the perpendicular distance between the two axes. H is the perpendicular distance between two parallel axes. One thing is important here. Now, one student, what is this? M is the mass of the body. Mass of the body. In this case, ring. In this case, ring. Clear? Now, question: one student has written like this. Sir, I1 equal to I1 plus M is square. Now, this is correct or this is correct? Which is correct or both are correct? Is there any difference? Answer is both are correct. No, this is wrong. Answer is this portion added to that I whose axis passes through the center. In this case, this is the center of the body. You can write this is I Y or you can write this is IC. With this IC, MH square, this portion is to be added. What is the answer? Sir, here IC, with IC, MH is added and another parallel axis, this I is the resultant. Please try to understand. Therefore, sir, this formula in this case wrong. IC plus MH square. IC plus MH square. That gives the
I1.
That gives the resultant. Clear?
I1 is
Here, please here. I1 or IC. This you can write I1, I2, I3. But what's the language of this? Its axis should pass through the center of the body. This is the important. Is it clear? Okay. Now, in this case, I am deleting this portion. Please, I am deleting this portion. Now, please see here. In this case, what is this? IC. What is the formula of IC? IC formula. This is M R square. What is this? Sir, this is M R square. In this case, M. What is this H? This H is R. What is this? R square. That equal to 2M R square. Please write down. Clear? Now, in this case, this is another tangent. I am drawing like this. I am like this. This is the tangent. Please see here. Please see here. Here is ring. Here is ring. This is the tangent in the plane of the ring. Here is the ring. Tangent is like this. That tangent is not in the plane of the ring. That tangent in the plane perpendicular to the plane of the ring. What? Now calculate. This is I2. What is the formula? In this case, its parallel axis is like this. Its parallel axis, and this is IZ. In this case, what is the formula? Sir, I2 equal to IZ plus MH square. What is this formula IZ? Here is the question. Here is the physics. What is this IZ? Ring like this. This is the center. With respect to this x, what is the formula for ring? M R square. What is this? Sir, this is M R square. That is wrong. Here I see is not M R square, this is M R square by 2. This is 2. What is this? This is 3 by 2. This is wrong. Please see here. What is this? IZ is M R square. IX equal to IY. Imagine. IZ equal to sir. IZ equal to M R square. IX equal to IY equal to M R square by 2. Therefore, this is 3 M R square. But here M R square, IZ equal to M R square. This is also M R square. That equal to 2 M R square. Is it clear? Now I am giving for uniform circular ring IZ equal to M R square, I X equal to IY equal to M R square by 2, and this is I1. This is tangent. Which tangent? In the plane of the ring. Tangent in the plane of the ring. What is the formula? 3 by 2 M R square. What is the formula? I2 2 M R square. 2 M R square. You can take capital M, no problem. This is capital M. Okay? Now what is the special question here? What is the special question? This is very important. Question is find. What is the find? Find number 1. IZ is to IX is the question. Number 2. IZ is to I1 is the question. I1 is to I2 is the question. IZ, what is the formula? We know. M R square. What is this? M R square by 2. What is the answer? 2 is to 1. What is this? IZ M R square. What is I1? I1 3 by 2 M R square. What is this? 2 is to 3. What is this? I1 3 by 2 M R square. What is this? 2 M R square. What is this? 3 is to 4. 3 is to 4. 3 is to 4. Is it clear? 3 is to 4. Okay? Next. Now, similarly, in case of circular disc, uniform circular disc, uniform circular disc. Uniform circular disc, please see here. I am writing, this is IY, this is is Ix, this is Iz. What is the formula of circular disc? Iz? M
R square by 2.
2. In this case, what is this? Theorem of perpendicular axis. Theorem of perpendicular axis. What is this? Set Ix plus Iy equal to Iz. Here Ix and Iy same. Here is m r square by 2. What is this? Ix equal to m r square by 4. Is it clear? Now, this is standard 1. This is standard 1. I am taking this is I1. What is the formula? What is the formula? Equal to Iy plus mh square. What is this h? Iy. How much? Iy, that equal to Iy. M r square by 4. This is m r square. What is the answer? 5 m r square divided by 4. Is it clear? Okay. Now, this is the tangent. This is the tangent. This is the perpendicular. This is the tangent. This is the tangent. With respect to this tangent, I am taking I2. Clear? What is the formula of I2?
M R square.
No. Iz square. Iz square now. Iz plus h square. What is the distance? Perpendicular distance. This is equal to 1. What is the Iz? This is m r square by 2. This is m r square. What is the answer? 3 m r square by 2. Clear? Okay? Therefore, uniform circular disc. Please write down uniform circular disc. Iz equal to m r square by 2. Ix equal to Iy m r square by 4. I1 5 m r square by 4. I2 3 m r square by 2. Clear? Okay. Next question. This is very important.
Sir, Ix to 5 by 4 bar होगा?
No. 5 by
As
4.
Ix equals to I1 as possibility.
Where is I1? This I1. This equal to this plus m r square. Is it clear? This is I1 5 m r square by 4. But I2 parallel axis theory. This is 3 m r square by 2. And what are the questions? Same type of question. Please see here. Question. Here Iz is to Ix. It's spelled before that Ix equal to Iy. This is the question. I1 is to I2. Question Iz is to I1. Question Iz is to I2. Easy question. If you know, this is very easy. What is this? M r square by 4 is to m r square by 4. 1 is to 1. What is this? Iz m r square by 2 is to Ix m r square by 4. That equal to 2 is to 1. What is this? I1 tangent 1 in the plane of the ring. In the plane of the ring. What is this? 5 m r square 4 is to, this is tangent 2. This is I2. What is this? I2 equal to 3 m r squared by 2. What is the answer? This is 4. This is 5 is to 6. 5 is to 6. This, what is this? Iz. Iz, what that is? M r squared by 2. What is I1? I1 is here. This is 5 m r squared by 4 is to 2 is to 5. What is this? This is Iz. M r squared by 2 is to I2. I2 3
M r square by 2.
I2. What is this? 1
1
is
is
to
to 3.
3. Is it okay? Next. Now, the question is, in case of in case of this is uniform, this is hollow sphere. Okay? It's Iz. We know what is Iz? That is IC. That equal to 2 by 3 m r square. Clear? Its quotient Ix. Its quotient Iy. Its quotient I1. Its quotient I2. What is the answer? First thing, here is a mistake. What is the mistake? Mistake is student will do like this. This is Iz, 2 Ix. What is this? 2 by 3 m r square. 2 cut. What is Ix? Equal to m r square, m r by 3. Sir, this is wrong. Why wrong? Because, please see here. This diameter, please here. This diameter, and this diameter. In this case, all the diameters with respect to all the diameters, I say here. Therefore, this Ix, Iy, Iz, that equal to 2 by 3 m r square. This is not a formula. It is wrong. Another thing, here I1, I2 not separate. Here I1 equal to I2. In case of sphere, it is in the plane of ring, it is also plane of ring. Therefore, I1 equal to I2. That's why, sir, here I1, I2 not separate. I1, I2 is the question. What is this? I1 plus I1 equal to I2. That equal to Iz plus m r square. What is Iz? Iz
2 by 3 m r square.
2 by 3 m r square, and this is m r square. What is 5 by 3 m r square? This is the answer. Please write down. 5 by 3 m r square. Clear? Similarly, in case of solid sphere, same. Similarly, solid sphere. Please draw the solid sphere. Solid sphere. In this case, here Ix, Iy equal to Iz. That equal to 2 by 5 m r square. Here I1, this tangent and this tangent same. This is I1, this is I2. All the tangents same. Here I1 equal to I2. That equal to, sir, Iz plus m h square. Iz equal to 2 by 5 m r square, and this is m r square. What is this? 7 by 5 m r square. Is it clear? Okay, next. Okay, this part is very important. See here. This is uniform rod. Here, with respect to this is IC. With respect to this is I1. What is the question? First answer. This here. This we know. What is this? M x square by 12. And this is the question. In this case, which theorem is applicable? Perpendicular or parallel? From the figure? Two axes, parallel theorem. Three axes, perpendicular. Two axes, simple answer. What is this? I1 equal to IC plus MH square. What is this formula? MH square by 12. What is this H? What is this H? What is this H? H equal to L by 2. L by 2 whole square. So what is this? Let's say 12. This is M x square. This is 4. This is 3. M x square. 4 by 3. That is M x square by 3. This is the answer. Is it clear? Okay? What is this? This is IC. What is the formula? Hollow cylinder. Hollow cylinder. M cylinder. Hollow cylinder. M R square. What is this R? This public is R. Clear? Now, this is place here. Now, question is, with respect to this axis, suppose this is I1. What is this question? What is the answer? I1 equal to IC plus MH square. What is that? This is M R square. What is it? What is H? What is H? H equal to R. What is the answer? 2 M R square. Is it clear? Okay, next. I am just changing. Draw U. What is this? This is the solid. What is this? Solids here. Solids. What is this? M R square by 2. What is this? I1. This is M R square by 2. What is the answer? This is 3 by 2 M R square by 2. Is it clear? Next. I am taking what is this? This is this here. In this case, please see. This is Ix, this is Iy, and this is Iz. What is the first theorem? Ix plus Iy equal to Iz. Is it clear? 2 Ix, here Ix equal to Iy. Ix equal to Y. Iz, what is the formula Iz? M A square by 6. What is Ix? M A square by 12. Is it clear? M square by 12. Now what is this? With respect to this, suppose this is the axis, this is I2. What is the formula? I2 equal to Ix plus M H square. What is H? Distance between two parallel axes. What is Ix? Ix equal to L A square by 12. This is L. What is this H? What is this H? This is whole is A. What is this? A by 2. A by 2 whole square. So M A square by 12 plus M A square by 4. This is 12. This is M A square. This is 3M square 4. This is M A square by 3. Okay? Today up to this. Thank you.